Go back to Educator.com. Today we're going to be covering some very important parts of C++, particularly object-oriented programming. Without object-oriented programming, you might as well use C. Okay, so far we've been dealing with procedural programming with C++, which it does just as well as any other language that's procedural. But the strength of using C++ instead of C is object-oriented programming. It's a somewhat different way of looking at design, programming, etc. for putting your applications together. Your data and structures are gathered into objects, which are defined into classes of objects, and they are isolated as much as possible from other objects. We emphasize important concepts. These particular concepts is abstraction, encapsulation, inheritance, and polymorphism. Some of this we've already seen in procedural programming, but we emphasize it more in object-oriented programming. C++ gives you multiple inheritance. Some other languages don't, some other languages do. But basically it means an object can inherit, in object-oriented programming, everything has a class which you inherit from other classes. But in C++, you can inherit from more than one parent class. So with multiple inheritance, it allows for various things. You can use different parts from different things, but you also have to be worried about the diamond problem, which we'll talk about later. And we're going to talk about construction and destruction of objects, which allocate and deallocate memory when they're necessary. Well, let's talk about a little of some concepts. Historically, what you've done is procedural programming, which means basically programming follows a procedure. And a procedure is similar to an algorithm, except that the only way you know for sure that things work properly is to test it. An algorithm technically is something you know is going to do a certain thing. A procedure is an algorithm that runs a certain way, and you are not 100% assured that it will go a certain way. Where the classical mathematical terminology is that it will end. You run it and it will actually come to a conclusion. Object-oriented line is similar to procedure, except for now, instead of just merely having procedures, we now also have objects that simulate objects in the real world. And again, we emphasize important concepts that you can do in procedural programming, but in object-oriented, they're emphasized. Abstraction, encapsulation, inheritance, and polymorphism. And I want to reiterate these because these are very important concepts that will be used in object-oriented programming. So again, the data structures are gathered into an object. An object is part of a class of objects, and then we'll talk about some of these other parameters in the next slides. Okay, let's get some terminology out the way. An object is a collection of related data, which are called attributes, and functions that operate on that explicit data in that object, and they're called methods. And it represents something in the real world. Car is an object. And in your car object, you might have your velocity, your location, how many passengers are in the car, etc., etc., etc. Now, a class defines the object attributes. And it can inherit from superclasses, or you can derive from a superclass into a subclass. An instance is an actual object with actual data, as opposed to just generically talking about objects or in classes and all this stuff. If you actually have an object instance, that is actually some code in your application that's actually running. For example, let's say we have a class called horse, which describe his weight, his age, when he was born, his owner, etc., etc. And we use that as a type and declare an object called Mr. Ed. The variable Mr. Ed is an instance of the class horse. Now, a derived class or subclass is the inheritor. It inherits from the superclass. The base class or superclass is the inheritee. He's the one who is inherited from. Like a horse may inherit many attributes from a superclass called animal or racing animal. Now, abstraction. Abstraction defines just the essential characteristics of the object or class of objects, particularly those that are needed for the task at hand. We want to emphasize essential. You don't necessarily want to have all possible data because that'll make your application too large. So you just pull out, abstract the ones that you need. For example, baking data will need the customer name, their address, the type of account, the date of the last deposit, etc., etc., etc. The customer's favorite team, not so important. We can leave it out of our banking application. We may want to use it in our sports betting application. But for this application, or whatever application you're working on, you have to analyze your situation and determine what data are you going to abstract into your system. And we also need to emphasize the characteristics that are different from one class of objects from another class. For example, we may have an employee data in an object, which has a name, a wage. We have a separate object called company, which also has a name. It also has an annual profit. Now, should these two particular objects have the same parent class? Maybe, maybe not, depends on your analysis. Should it be the same class? Because after all, wage is a $sign, annual profit is a $sign. Well, you probably don't want to make them the same object. For one thing, your methods that will be applied against this data will be different. Yes, you need to enter the name, you need to print out the name, but your wage, the employee pays taxes on their wages differently than a company pays taxes on their annual profit, etc., etc., etc. So because these, in the real world, they're certainly distinct objects, and they're definitely different from each other. So in our application, we want to abstract them into two different objects in our application also.